Hi, before we start this next set of examples on rational functions and limits of rational functions as x approaches infinity, let's talk for a moment about what a rational function is. And a rational function, in its simplest terms, is simply a function that includes a fraction. Technically, it's a little bit better defined than that. But really, what we're interested in here is the fact that we're talking about fractions, functions that include fractions. So let's look at what happens to a fraction, to certain fractions, as the x involved in the fraction becomes closer and closer to infinity. We're going to look at some examples in particular. We'll look at 1 over x, we'll look at 1 over x squared, we'll look at 3 over x, and we'll look, let's say, at 5 over x squared. And we've picked those pretty much at random because the numbers in fact don't matter, and that's what we're going to try and show here. So we'll go to our calculator and we'll enter those functions in our calculator. So 1 over x, 1 over x squared, three over x we said, and 3 over x squared. Sorry, 5 over x squared. So let's go back and change that to 5. Okay, now we've done this before. We're going to set up our table. So second and table setup. And we want to make sure that the independent variable is set to ask. That's the only thing that matters. When we have the independent variable set to ask, the table start and delta table entries don't matter. So now let's go to the table. So second and table will bring us to the table. Remember, y1 is 1 over x, y2 is 1 over x squared, y3, which we'll scroll over to in a second, is 3 over x, and y4 is going to be 5 over x squared. Now we get to choose our x's, and we want these x's to get closer and closer to infinity. So let's start with 1. Okay. And we can go, another x would be 10, and 100, and 1000. Okay, now if we look at y1, now y1, remember, was 1 over x, then our answers are 1, 0.1, 0.01, and 0.001. Okay, now this is the trend in 1 over x as x itself gets bigger and bigger. So as x gets bigger and bigger, 1 over x gets closer and closer. Hopefully you can see 1, 0.1, 0.01, 0.001. It's getting closer and closer to 0. Okay, so as x gets bigger, 1 over x becomes closer and closer to 0. For 1 over x squared, that's the y2 column right here, the y2 column right here, the impact is even more pronounced. So when x is 1, 1 over x squared is also 1. When x is 10, 1 over x squared is 0.01. 1 by 10 to the power of minus 4, that's 0.0001. And 1 by 10 to the negative 6, 0.000, 6. And again, even quicker than the last one, this one is also going to 0. This fraction becomes 0. So, as x becomes 0, 1 over x squared, as x becomes closer and closer to infinity, remember the x's were 1, 10, 100, 1000, 1 over x squared is getting closer and closer to 0. Now let's just move this out of the way a little bit, give ourselves a little bit more room here. So we'll put our 3 over x here, and what do we have? 5 over x squared here. Again, let's scroll over so that we can see what y3 and y4 are. When x is 1, 3 over x is 3. When x is 10, 3 over x is 0.3. when x is 100, 3 over x is 0.03, and when x is 1000, 3 over x is 0.003. Once again, even though the number on top is different, these numbers are getting closer and closer to 0. Okay? And then finally, 5 over x squared. As x gets bigger and bigger, you can see what's happening to the 5 over x squared again. When x is 1, 5 over x squared is 5. When x is 10, 5 over x squared is 0.05. When x is 100, 5 over x squared is 0.0005. And then finally, when x is 1000, 5 over x squared is 0.0001, 2, 3, 4, 5, and then 5. Again, these numbers getting closer and closer to 0. So, as x moves closer and closer to infinity, then if we have a fraction, anything on top can be anything on top, so we'll use a for anything can be on top, any number that is, then a over x to the power of n, where n is a positive number, is getting closer and closer to 0. And in fact, if x is getting closer and closer to minus infinity, in other words, if we started off with x being -1, -10, -100, -1000, then the only change would be a minus sign in front of the numbers that we have in our table. In either case, whether it's plus or minus infinity, a over x to the power of n is going to get closer and closer to 0. That is the one little conclusion that all the following exercises are going to depend on. So as x gets closer and closer to plus or minus infinity, then a over x to the power of n, where a is any constant and n is any positive constant, that fraction, the fraction gets closer and closer to 0. As x gets bigger and bigger, in other words, as the bottom of the fraction gets bigger and bigger, the value of the fraction itself gets closer to 0. Okay, that's it for this one. Thank you.